deep beneath the surface of the world's most remote oceanic trenches, where sunlight surrenders to eternal darkness and pressure reaches crushing extremes, there exists a creature so rarely observed that many marine biologists have spent entire careers without glimpsing even a shadow of its form. This is Lugia, apex predator, atmospheric engineer, and perhaps the most remarkable vertebrate to ever evolve in Earth's oceans. Before we descend into those lightless depths, a quick note. If you value these scientific expeditions into the world's most extraordinary species, subscribing takes just a second and helps keep this research going. Now, let us begin our journey into the abyss. The first challenge in studying Lugia is simply reaching its habitat. At depths exceeding 6,000 meters, the pressure would instantly crush conventional submersibles. Yet, Lugia thrives here, its body a masterwork of evolutionary engineering. The creature's skeletal structure is unlike anything else in the animal kingdom. Composed of a lattice-like bone matrix filled with specialized lipid chambers that resist compression while maintaining buoyancy. Each vertebra interlocks with precision, creating a flexible yet incredibly strong spinal column capable of withstanding forces that would pulverize steel. The specimen we're tracking is approximately 17 feet in length, though larger individuals have been theoretically documented through sonar imaging. Its coloration, a silverant silver-white with blue undersides, serves a purpose beyond aesthetics. This counter-illumination camouflage makes the animal nearly invisible when viewed from below against the faint bioluminescent glow of the deep ocean and from above against the marginally lighter waters. What truly distinguishes Lugia from all other deep-sea organisms is its unprecedented respiratory system. Within its chest cavity lie enormously developed swim bladders that function not merely for buoyancy, but as biological compression chambers. Through muscular contractions of extraordinary force, Lugia can expel air with such velocity that it generates localized pressure differentials in the surrounding water, essentially creating underwater wind currents. Marine seismologists have detected these expelled air masses as acoustic signatures on deep ocean monitoring equipment, often mistaking them for tectonic activity. The expelled gases, superheated by compression and friction, create cascading thermal columns as they rise through the water column. Local fishermen have long spoken of sudden storms appearing over seemingly calm seas. What they don't realize is that far below, a Lugia may be ventilating, sending massive air currents toward the surface that disrupt atmospheric pressure systems for miles around. In the absolute darkness of the Hadal zone, Lugia's eyes have evolved into something almost alien. Each ocular organ is roughly the size of a grapefruit, with pupils that can dilate to extraordinary dimensions. But unlike typical deep-sea organisms that rely on simple light detection, Lugia possesses what appears to be the most sophisticated visual system ever documented. The retina contains not millions but billions of photoreceptor cells, allowing it to detect individual photons of bioluminescence from miles away. More remarkably, specialized cells within its eyes appear capable of detecting minute electromagnetic fields, an adaptation that allows it to sense the nervous systems of prey animals in complete darkness, essentially seeing their bioelectric signatures through the water itself. What does such a creature consume? Our remote sensing data suggests Lugia feeds primarily on large deep-sea organisms, giant squid, gulper eels, and occasionally even small whales that dive to extreme depths. The hunting strategy is one of patient ambush. Lugia will position itself in underwater canyons, using its air manipulation abilities to create subtle currents that carry prey scent molecules directly to its highly sensitive olfactory organs. When prey approaches, the attack is sudden and devastating. Using its powerful pectoral appendages, which function as both fins and grasping limbs, Lugia strikes with remarkable precision. The beak-like structure of its mouth can generate bite forces exceeding 12,000 pounds per square inch, sufficient to crack the reinforced cartilage of giant squid or the spinal columns of large fish. Perhaps most fascinating is Lugia's role as an ecosystem engineer. By circulating deep ocean waters through its atmospheric expulsions, it distributes nutrients from the abyssal zone to the surface waters above. Areas where Lugia have been documented show unusually high productivity in surface phytoplankton, the foundation of the entire oceanic food web. In this way, this solitary, deep-sea predator influences life across thousands of vertical feet of ocean. The creature's migratory patterns remain largely mysterious. Tagged individuals have been tracked moving between oceanic trenches separated by thousands of miles, suggesting either incredible stamina or the use of deep ocean currents we have yet to fully map. As our submersible ascends and pressure gradually releases, one truth becomes undeniable. In the deepest, most inhospitable regions of our planet, evolution has crafted not a monster, but a guardian, a creature so perfectly adapted to its realm that it shapes the very waters that surround it. Lugia represents the ocean's most carefully kept secret, a reminder that even now, in our age of satellite imaging and drone surveillance, the depths still harbor wonders beyond our complete understanding.